Well, thank you for that introduction, Amy, and thank you all for coming to join us today for the lunchtime expedition at the Buffalo Bill Center of the West. Today I'm going to be talking about a project that we've been working on for quite some time in Buffalo Bill Reservoir, just west of Cody here. And I'm going to talk about an illegal introduction of walleye. But before I delve into what we've been doing on Buffalo Bill Reservoir, I want to kind of preface this with some fish introductions that have occurred in the past. There's a storied past of fish introductions, and there's a complex history in the United States. With westward expansion, fish introductions were conducted to help fuel westward expansion. Intentional introductions were done by individuals and fisheries agencies to provide a food resource. And in 1871, the United States Fish Commission, the United States Commission of Fish and Fisheries was established, and that played a key role in distributing fish and promoting fish culture in the western United States. Particularly through the establishment of fish hatcheries in a number of places. But if you think about it, this happened just 2 years after the construction or the completion of the Transcontinental Railroad, and this was 19 years before statehood in Wyoming. And these fish introductions created a legacy that we deal with today. Back in 1869, the Wyoming Territorial Legislature had a bill that essentially established what became the Game and Fish Commission and the Game and Fish Department, but that bill protected fish and game resources in the state of Wyoming. In 1880, again 10 years before Wyoming was a state, the first fish commissioner was appointed. I'd like to point out to my red-shirted friends that are on the terrestrial side that the first fish warden was created almost a decade before the first game warden. So it's something that I like to point out to those folks. And from the 1880s through the 1930s, for 5 decades, fisheries management was exclusively about fish propagation and distribution. So people were spreading fish all over the place before we even knew what fish were on the landscape. And it wasn't until the 1930s when the first field surveys were actually conducted, and those surveys were done to try to determine how to allocate stocked fish resources better. In 1950, the Dingell-Johnson Act provided some revenue through the taxation of fish and fisheries equipment that was redistributed throughout the states. And from the 1970s through present, there was an advancing ecological awareness of what was happening with all of these fish introductions. So if you think about it, there was an evolution in fisheries management, which that evolution kind of changed with changing societal pressures and desires of folks within the society. So we went from the sowing of crops, which was these introductions that occurred all over the place, to how can we maximize the amount of fish that we can take out of these resources, to obtaining what we would identify as the optimum yield, whether that's the, maximizing harvest in some places, maximizing angling opportunity for some places, but we're also looking at balancing ecosystem function and the management of native species as well is something that has been happening and evolving since the 1970s. So if we think of fish introductions here locally, things have been occurring across the West, but many of you probably are familiar with the lake trout in Yellowstone Lake. It's been highly publicized. And there's a Sisyphean effort to try to reduce the impacts of that lake trout introduction to the cutthroat fishery in Yellowstone Lake. And based upon the information from my colleagues, they're doing pretty well. But we've got introductions that have been occurring throughout the state as well. I just wanted to highlight a few of these. Some of them have been warm and cool water fishes. You know, we've got Burbot and Flaming Gorge and Fontenelle reservoirs and have been established throughout the Green River drainage. We've had yellow perch introduced into a number of local waters, including West Newton, Harrington Reservoir. Most recently, yellow perch were introduced into Saratoga Lake that's just west of Laramie. We've had walleye that have been introduced a number of places, including De Smet and Buffalo Bill Reservoir that I'll talk about today. And oftentimes these illegal introductions, or in some instances the legal introductions, have served as a beachhead for the additional distribution of these fish illegally into some other waters. And so when these introductions occur, they have a pretty dramatic effect on the entire aquatic ecosystem. There are cascading effects that happen throughout the entire ecosystem. And once these introductions happen, once they become established, it's nearly impossible to manage or overcome. In some instances, we can use the chemical rotenone to completely remove all fish and start from scratch. That was something that happened just a couple of years ago with the Saratoga Lake yellow perch. When yellow perch were identified in Saratoga Lake, at a cost of just over $100,000. They had to drain and chemically treat Saratoga Lake to get rid of that yellow perch introduction. But in a water the size of Buffalo Bill Reservoir, our ability to do something like that just doesn't exist. All of these introductions came to a head in 2010. The 60th Wyoming legislature passed what became Statute 234101, which prohibited the stocking of waters and established penalties for those. Now there were restrictions and limitations on introductions prior to this point, but what I wanted to point out here is that it created a high misdemeanor. The penalties for a high misdemeanor are a $10,000 fine and up to a 1 year imprisonment, it included the revocation of any licenses and the suspension of a person's privileges up to lifetime. So if someone really likes to fish and wants to conduct these illegal introductions, they could have their hunting and fishing licenses revoked for life. And that's not just in the state of Wyoming, because Wyoming is a participant in the Violators Compact. You could have your hunting and fishing privileges revoked in all of the United States. So now, that being said, it's extremely difficult to try to prosecute someone for these illegal introductions, but this was established in order to try to avoid people because there are some fairly serious consequences. In addition, civil penalties can be assessed that would cost for the removal or mitigation of those fish that were introduced. So although it's just a high misdemeanor, it's still a pretty serious crime. So let's talk about locally here. We're in Buffalo Bill Reservoir and the North Fork Shoshone. Most of you probably are fairly familiar with this. Buffalo Bill Reservoir is a fairly old reservoir. It was built from 1905 to 1910. It was enlarged in the mid-1990s. It's just over 8,200 acres at full pool, and it's a very unique trout fishery in that most of our large reservoirs in the state of Wyoming are stocked with trout in order to provide that angling opportunity. But in Buffalo Bill Reservoir, these fish have adapted to migrate up the North Fork Shoshone and spawn, and their progeny repopulate the reservoir. So for the last 5 decades, we have not stocked the North Fork Shoshone or in Buffalo Bill Reservoir. The North Fork itself is fairly steep. It has low to moderate productivity, but because of this pulse of fish that come out of the reservoir every year, we have an abundance of fish in that river that the river would not be able to attain were it not for that reservoir. Because of the high biomass of fish that are in that river, it's classified as a blue ribbon, and it ranks in the top 3% of all fisheries in the state of Wyoming, and our agency considers blue ribbon fisheries as fisheries of national importance. And as I said, annually those fish will migrate. The adult fish will migrate up out of Buffalo Bill Reservoir into at least 26 spawning tributaries in the North Fork Shoshone, where they reproduce, and those progeny drift back to the reservoir to grow and mature. And so it provides angling opportunities in both the reservoir and in the river itself. So in 2008, walleye were first documented in Buffalo Bill Reservoir. And before I start talking about this introduction, there's a couple of things that I need to discuss. This picture on the bottom here is an otolith. It's a sagittal otolith. It's an ear bone that is found in fish. And you might be saying, well, fish don't have ears. But they do have these ear bones. They use it for balance and a number of other things. But as you can see in this image, there are a number of bands that are in this otolith. These bands are referred to as annuli. So every year, the fish will put down a new annulus. As that fish grows and ages, you can actually age a fish by counting the number of rings that are in this otolith. The otolith is primarily composed of calcium, but there are other chemicals that it assimilates in the otolith as it is developing. Some of those chemicals are the chemical strontium, and strontium is present on the periodic table there. It has a number of stable isotopes, and particularly strontium 86 and strontium 87 are present at a variety of ratios across the landscape based upon the geology. And what that allows us to do is, if you look at the ratio of strontium isotope in a given in a fish, for example, if you looked at the strontium isotope in an otolith at a given period of time, you can it can help determine where that fish was at that period in time. So, if we take a look at this is another picture of an otolith here. You can see these numbers represent the strontium stable isotope ratios. These are little holes that were drilled into the otolith, and those are the values of the ratio of strontium 86 to 87 that was present in that otolith. And then this, the laser ablated this. You send all that information through the chemical spectrophotometer, and it tells you what that ratio is. So this is from a number of small walleye that were from 8 to 10 inches that were captured in Buffalo Bill Reservoir. As you can see, there's a lot of variation in the strontium stable isotope here. But we also caught 2 large fish, which we are calling founder fish, that were likely from the initial illegal introduction. And as you can see, their strontium isotopic signature shifted from being just north of 0.708 to right just south of 0.707. Now That is a pretty dramatic shift in that isotopic ratio. We went and collected water samples from a number of places that also had walleye and found that the most likely place that those fish originated was Draper Reservoir. So we were able to not only source where this illegal introduction came from, but also when that introduction occurred, because we captured these fish in 2008 and 2009, but we were able to, by looking at the ages in which that shift occurred, count back to when those introductions occurred. So we know that it was an illegal introduction. Like I said, no stocking has occurred in Buffalo Bill Reservoir for 5 decades, and the most likely source was from from Draper Reservoir back in around 2002 and 2003. So when we found walleye in 2008, we were really cautious because there have been a number of places where we've seen impacts to trout fisheries from the introduction of walleye. So we implemented an emergency regulation that removed limits on the amount of walleye that could be captured. We also started a number of regulatory and management actions to try to limit impacts from walleye. So those things included sampling to determine where walleye were located and if there were places they were congregated. We, in 2009, implemented an unlimited walleye regulation, and then after undergoing a few administrative hoops, we turned that into a must-kill walleye regulation in 2014. We also had to, because of our want waste statute and not wasting, we had to turn walleye into a non-game fish in order for that to occur. In 2014, we started conducting electrofishing removal of walleye from spawning congregations, and in 2016, we started to gill net in addition to our electrofishing. We also had 2 major master's theses that were done as a part of this project. In 2012, we began looking at what the food web was, and I'm going to go into what a food web is. And then in 2016, we began looking at the feasibility of potentially suppressing walleye. In 2018 and 2022, we also attempted 2 means of conducting radiotelemetry using what are referred to as Judas fish. So we would catch some fish, insert them with transmitters so that we could follow them when they went to disperse into the reservoir, and we're hoping that during the spawning season we would be able to identify additional locations for spawning. We used radiotelemetry in 2018, which is a method where a radio signal, there's a little radio transmitter that you surgically implant into a fish and then follow it with a radio receiver. And in 2022, we attempted using acoustic telemetry, where it's not dissimilar from the way a GPS unit works. We put out a number of hydrophones. We attempted to do this, but our read range for our hydrophones was insufficient. So what we were intending to do is to identify if there were any additional spawning locations. This is kind of just a quick snapshot of all of the work that we've been doing to try to assess where we were going with walleye in the reservoir. So that food web study, a food web is essentially looking at who's eating whom in a given water body. So it entails collecting a bunch of fish, looking at a number of stomach contents, and they call it a web because it can get very, if you look at the interconnection of all those different species, you can start to see a web forming where the arrows are forming this web of lake trout and crayfish and rainbows and cutthroats and zooplankton. So what we were looking at is really who's eating whom, developing what that food web structure is, and then trying to quantify how much each of these top-level predators are consuming. At the time, we believed we had an expanding lake trout population, so we wanted to ensure that with the addition of another top-level predator like a walleye, we were going to be able to sustain our rainbow cutthroat fishery, which is really kind of the bread and butter of what the Buffalo Bill Reservoir fishery is. The food web study also used a bioenergetics model to quantify over the lifespan of one of these fishes what its total impact might be. So what we found is that really lake trout weren't having a huge impact on our Oncorhynchus or our rainbow cutthroat fishery. So it was only the big lake trout, which are greater than 600 millimeters, and only during the mixed period. So that M is the time period when we've got mixing of water, so it's not stratified. The S suggests when the reservoir is stratified. So it's only during the mixed period where we have large lake trout that are consuming many of our rainbows or cutthroats, which are Oncorhynchus, the black bars in this graph. And walleye, all size classes of walleye were consuming those Oncorhynchus, the rainbow cutthroats. And if you look at it from, whether you look at it from just a diet frequency perspective or a bioenergetics perspective, walleye were by far consuming more rainbows and cutthroats than walleye were. So we thought that we had a problem. This confirmed that we did have a problem. And using bioenergetics, a age-structured population model was constructed that suggested it wouldn't take a very large number of walleye to have a significant impact on our rainbow cutthroat production in the reservoir. So the next thing that we had to determine is there anything that we can do to change what is the toothpaste is out of the tube, so to speak. We already have walleye that are present. Is there any way that we can affect the management of the fisheries resource in Buffalo Bill with this new introduction? So we wanted to determine if suppression of the walleye population is feasible. We had this graduate student, Daniel Cause from Montana State University, that collected a bunch of information related to a lot of the vital rates for that population of walleye in the reservoir. So those vital rates included at what age do the female fish mature, how many eggs of a given age does a female walleye produce, what is the natural mortality of walleye in the population, and then if we created some additional mortality by fishing for those, whether it's angling or by netting, is there anything that we could do to reduce or increase the mortality to the point where we could reduce that population? So collected a lot of information from a lot of different fish during this graduate study. In addition, we tagged a bunch of fish, and we tagged a bunch of walleye and let them go. And the wildlife supervisor that was here at the time kept asking me, well, if you want to get rid of them, why are you putting them back out there? Which is a good question. But what we had to determine is what kind of problem or what kind of population are we dealing with out here? So we did a population estimate. So we marked a bunch of these fish and released them into the reservoir and conducted a mark recapture population estimate. And we also had reward values on a lot of these fish so that we could pay anglers to report whether or not they caught these, and it would allow us to estimate how much exploitation or how much angler harvest is occurring on this walleye population. We also did a gear evaluation. So we looked at a number of different methods to try to capture walleye. We used trap nets, which is this device that we're deploying here. We conducted electrofishing, which is putting pulsed DC current into the water and capturing those fish as they came up. And we also did gillnetting, which is stringing these nets out and allowing fish to entangle in those. So all of that information was integrated into our age-structured population model. So all of these walleye that we're collecting, we are removing the otoliths from those walleye and then using that to integrating that into the age-structured population model. So what we found is we actually had a fairly modest abundance of walleye in the reservoir. At the time, and we're only looking at sexually mature individuals here, we only had just over 500 female walleye that were greater than 6 years old. We had just over 900 males, which are including all of those that are greater than 3 years old. Males, unlike in humans, males tend to become mature earlier than females. So we were looking at males that are 3 years old, females that are greater than 6 years old. And we had a fairly high exploitation. So anglers were harvesting about half of that population every year. In addition, we systematically sampled throughout the reservoir, and this map shows all of those sample points. So we were systematically electrofishing all of those places throughout the reservoir. So between each of those dots, and what we found is there was really only one major spawning congregation that was occurring in the reservoir. So perhaps we had an Achilles heel that we could exploit in order to reduce that walleye population. So we integrated, like I said, all of the information that we gathered in that in this graduate study to model what that population looks like. So if you look at the number of females at each age and the number of eggs that they produce, and you can model what that population is going to do over time. And this graph is something that you're going to see a number of times. I just want to describe what we're looking at. So this is the number of simulations given the parameters that we collected from that walleye population. And one is a population growth rate that is stable. So anything greater than 1 is an increasing population. Anything less than 1 is a decreasing population. And the shape of this bell curve, this is just the number of simulations. So if you have a wider bell curve, you are less confident over what your point estimate is of the mean right here. So looking at this, if we did nothing, we would have a population growth rate of 1.22. That means the population continues to grow, and on the next slide, I'll show you what that looks like over time. If we only conducted electrofishing, we were removing a large number of males, but you don't limit a population by taking out males. You have to take out females because a male will spawn with multiple females, and females are the ones that are really the target of our exploitation if we want to limit that population. If we just did electrofishing, we would reduce our mean population growth rate to 1.18. So it's still well above 1. If we were gillnetting, we got closer to 1, but we were still less than 1, or I'm sorry, still more than 1. So 1.04 is our mean population growth rate with just gillnetting. And based upon our angler exploitation, we could, in theory, limit that population by just having anglers take out a large number of walleye. Unfortunately, you can see that bell-shaped curve is a lot wider. Our confidence around that point estimate is less. But if you look at unlimited angler exploitation, in addition to us conducting our gill netting, we are below, that population growth rate is well below 1. It is actually 0.81. So we can limit that population. What does the projected populations look like under those different scenarios? So if we did nothing, we would see an exponential increase in the number of walleye that we had out there. If we electrofish, we would still see an exponential increase, but that it would taper off just north of 50,000 fish. If we conducted gill netting, we would see some variation, but it would be still on the order of 18,000 fish. And then angling and gill netting and angling, you can see those population projections. So that's what our graduate student told us that developed this model. This is what we could project. So it looked as though we could feasibly affect change out there. So from 2018, that graduate student finished in 2017. From 2018 through last year, we have been suppressing the walleye population using both gill netting and unlimited angler harvest. So for those of you that are not familiar, this is what a gill net is. You've got weights and flags on both sides, and then you have a net that's stretched out, and fish entangle themselves. Oftentimes they get their gills caught. That's why it's called a gill net. We extract the otoliths from all the walleye that we capture, and then we continue to feed that back into that age-structured population model that we talked about. The otoliths have been processed at the Fetzer lab at the University of Wyoming. One thing about gill netting, though, is that it's very size selective. So this is the size of the holes, if you will, in the gill net. So it's a monofilament net. It's 2 inches between the knots. We generally catch fish that are from 16 to 20 inches long. So the bigger the holes in the net, the bigger the walleye that you catch. And this is the amount of net that we've put out over the last several years. So we are generally conducting this netting operation the last 2 weeks of April and the first week in May. So nearly 3 weeks of effort. And we're each of these nets is 100 foot long. So every day of those 3 weeks, we're generally fishing about a mile of net on those spawning congregations in order to try to reduce the walleye population out there. And this is the amount of effort of the various sizes of mesh that we've fished over the last several years. What has our one of the metrics that we look at is our catch per unit effort. So that is how much effort does it take for us to catch any individual walleye. When we started in 2017, we were capturing just over 0.65 fish per net night. So that's still only about 1 fish every 2 nets. But since 2017, our catch per unit effort has continued to decline. It's varied over time, but on average now we're catching only 1 walleye in every 5 nets. But the effort in all meshes is not universal, as you can see. As you could see on a prior graph here, we're catching a lot of those 17 to 20 inch fish in the 2-inch mesh nets, and we have also there have been years where we haven't fished very many of those 2-inch mesh nets. And so if you look at just our catch per unit effort based upon the size of mesh that we're fishing, In that 2-inch mesh nets, we were catching an average of just over 1.2 fish per net in 2021, but that has continued from that time, has essentially continued to decrease. And from 2017, when we were catching a lot of big walleye, those numbers have diminished pretty substantially. We're not catching big walleye out there any longer. So how many do we remove during this operation? It's really not that many. The number of females removed has been, with the exception of 2017, has been fewer than 200 female individuals. So it's a really low number of fish, but it's still very important. If you look at the ages of fish that we've been catching, you can draw what's called a catch curve. And what this does, essentially the slope of this line, allows you to determine what the survival or mortality of the walleye population is doing. So the steeper the slope, the higher the mortality rate. The flatter the slope, the less the mortality rate. And you can think about it this way. If in this instance we had some number of fish that were 12 years old, the next year, if you had half that number of fish that were 13 years old, that would suggest that you had a 50% mortality rate. So we utilize these graphs, which are called catch curves, in order to calculate what are these annual mortality and survival estimates. There's a lot of numbers up there. I don't anticipate that you're supposed to understand everything that's going on, but there's two ways that we're looking at these survival rates, which are plugged into that model. We use this Chapman-Robson method because it gives us an error associated with their survival, which helps us determine what the variation of our different scenarios are. So looking at some more bell curves, this is our simulated population based upon the inputs from our sampling that has occurred from 2018 through last year. And as you can see, in most years, we are to the left of 1. So that population is shrinking. It's only been in 2019 and 2020 when we have had an expanding walleye population. In all other years, we've been to the left of that line, which indicates a stable population. So we've been shrinking that population. If you look at that another way, this is just, again, that the mean lambda, which is that population growth rate, and these are 95% confidence intervals. It's only in 2019 and 2020 when we've had an expanding population. In all other years during our suppression, we've actually been shrinking that population. And in years such as last year, the 95% confidence interval suggests that we're absolutely shrinking that population. So what does this cost? That's a question that I get often. The total cost of all of our nets, which have to be replaced periodically and mended annually, is around $10,000 just for us to deploy those nets. We've got boats, motor, and fuel that we have to that we utilize every year. We have a crew of 3 that goes out to conduct this work, and it tends to cost us around 400 person hours every spring. And where are we going from here? The modeling suggests that our suppression is keeping the walleye population from growing. We still continue to have a robust trout fishery in the reservoir because of our suppression efforts. We've been looking into the potential to contract these suppression activities. Some of you that are familiar with the effort that's going on in Yellowstone Lake, they've actually hired Hickey Brothers Research, which comes in and does a lot of their gill netting to remove the lake trout from Yellowstone Lake. We've been in contact with them about potentially assisting with our suppression activities because it's a large task for us to do every year, and it doesn't allow us to do much of the other work that is necessary to do that time of year as well. We're going to continue to try to investigate additional spawning sites, and there are other possible suppression-related activities that we could be doing. I've been developing some ideas related to additional angler incentives, because it's essential for our anglers to continue to be targeting these walleye. That is one of our primary ways of reducing that population is angler harvest. We've been looking at ways in which we could implement a daughterless technology. If you want to learn more about that, I'm giving a presentation at the Meeteetse Museum here next month related to some of the work that we've been doing with brook trout in order to try to reduce or eliminate brook trout populations in some of our cutthroat fisheries. And there are potentially other ideas that we don't have at this time, but currently we're going to continue to conduct our suppression activities to try to keep that walleye population low. I wanted to acknowledge Travis Niebling, who is our reservoir research biologist, the Cody Fisheries management crew, the spawning crew, and many others with the Wyoming Game and Fish Department. The partnership with the Fetzer Lab and the aging of our otoliths has been very important for continuing to feed that age-structured population model. And then wanted to acknowledge the folks at Montana State University and Colorado State University for the graduate projects that were done to help inform what we're doing out on Buffalo Bill Reservoir. And I know there was a lot of complexity to the stuff that I was talking about, and I'm sure there will be some questions that I would be happy to answer.